Let's begin by looking at the function f of x equal to 3x divided by the quantity x squared minus 9. Now I want to point out that this is a rational function. We are working with rational functions in this section. And a rational function, recall, is when we have a ratio of two polynomial functions. So here we do have a ratio, we have a fraction. The numerator is a polynomial function. 3x is a polynomial function, and the denominator is also a polynomial function. X squared minus 9 is a polynomial function. So when we have a ratio of two polynomial functions, we call that a rational function. Now we're going to look at how to determine vertical asymptotes algebraically, but I first want to begin by just looking at the graph. This is the graph of this rational function. And I want to take a moment to think about what is happening to this function as we approach certain x values. For example, what is happening to the function as we approach x equal to 3? So here is x equal to 3. As we approach 3 from the left, our function is going to negative infinity. And then as we approach x from the right, our function is approaching positive infinity. Anytime this happens, anytime our function is approaching either positive or negative infinity, or both, as we approach some x value, either from the left or the right, we have a vertical asymptote. If we look at the x value x equal to negative 3, we also have a vertical asymptote, because as we approach x equal negative 3, as we approach that x value from the left-hand side, notice our function is approaching negative infinity. So that makes this value a vertical asymptote. Same thing is happening as we approach x equal to 3 from the right. Our function is approaching positive infinity. Oftentimes we will include the vertical asymptotes as dotted lines on a graph so that we can see them better. So here I've included the line x equal to 3 and x equal to negative 3 as dashed lines in our graph. Now it's important to realize that these dotted lines are not actually part of the graph of the function. They are just indicating where those vertical asymptotes are. So in looking at a graph, we can visually identify where the vertical asymptotes are. But how do we determine vertical asymptotes if we're not looking at the graph? How do we do it algebraically by just looking at the function? And that's what we're going to do next. So to find vertical asymptotes of this function, we begin by making sure that the rational function is simplified. So we want to make sure that there aren't any common factors in the numerator and denominator. So let's factor the denominator of this function. So f of x we can rewrite as 3x divided by, and then the denominator is a difference of two perfect squares. So it factors into x minus 3 times x plus 3. So now notice that after factoring, notice that the numerator and denominator do not share any common factors. It is simplified. Now vertical asymptotes occur at values that make the denominator 0. So we ask ourselves, when is that denominator 0? The denominator is 0 anytime any of the factors in the denominator is 0. So in this case, when x equals 3, or when x equals negative 3, we get a 0 in the denominator. And so there are our two vertical asymptotes, which we saw in the beginning in our graph. So let's look at another example where we're asked to determine the vertical asymptotes of the function. So what we want to do here is first recognize that we have a rational function. Both the numerator and denominator are polynomial functions, making it a rational function. And our first step is to try to simplify. So if we need to factor the numerator and denominator, so we have an x minus 2 on the numerator, and the denominator we can factor out an x. So if I factor out an x, we're left with an x squared minus x minus 2. We can factor the denominator one step further. So the denominator, we can factor the x squared minus x minus 2. That factors into an x minus 2 times an x plus 1. So now notice we have a common factor in the numerator and denominator, so let's cancel those out. Cancel out the x minus 2 in the numerator, x minus 2 in the denominator. So now our rational function simplifies into, we have a 1 over x times x plus 1. So now that we've simplified, now we ask ourselves, when is the denominator equal to 0? So we set each factor to 0. So we have an x equal to 0 and an x equal to negative 1. Those are our two vertical asymptotes. And I want to point out that x minus 2 that we canceled out in the numerator and denominator, x equal to 2 is not a vertical asymptote because x minus 2 was a common factor in both the numerator and denominator. And now if we look at a graph of our rational function here, we do see where our vertical asymptotes are, x equals 0 and also x equal negative 1. Notice how as our function approaches negative 1 from the left, our function is approaching positive infinity. As we approach a negative 1 from the right, our function is approaching negative infinity. And then at x equals 0, we also have a vertical asymptote because as we approach 0 from the left, our function is approaching negative infinity. And then as we approach 0 from the right, our function is approaching positive infinity.